This video is for Algebra Section 6.4, Solving Compound Inequalities. Our learning goal: the learner will apply knowledge of compound inequalities to solve them and graph the solution set. So we'll be solving inequalities just like you did in Section 6.1, 6.2, and 6.3, and then you'll be graphing them on a number line. Compound inequality is our first vocabulary term. A compound inequality is a set of inequalities, usually two, connected by a conjunction, so and or. And then you will be doing the intersection and the union, depending on the problem. Intersection is the portion of the graph where the two separate graphs overlap. So if I graph the two inequalities separately, and then I put them together, wherever they both covered would be the intersection. The other one is the union. The union is the portion of the graph that at least one of the separate graphs covers. So these are going to be your statements that have an or in them. And if you graph the two inequalities, the union is where at least one of those graphs covered. It doesn't have to be just where they overlap. All right. Our prerequisite skills: you need to know how to graph on a number line, and you need to know how to solve inequalities, which is what we did in the first 3 sections of this chapter, so you should know that. Your homework today will be section 6.4, practice worksheet, evens only. Only have to do evens. All right. Let's do some example problems. So number 1 says graph the solution set of each compound inequality. So for number 1, it says b is greater than -1. And it says b is less than or equal to 3. And you may need to do this on separate paper because they only give you one number line, but you need 3. So unless you can draw in another couple of number lines in there, you really need 3 to be able to do this correctly. So b is greater than -1. I would draw my number line. I want to make my number line go from probably -2, -1, 0, 1, 2, 3, and 4, because we need to go up to 3 for the other one. So it's going to be greater than -1. That means it doesn't include it, so it's a circle. And if it's greater, it points this way. So it's going to go over here and put an arrow. Then my other inequality says b is less than or equal to 3. So I'm going to draw the same number line. 2, 3, and 4. And it's less than or equal to 3, so it includes 3, so put a dot. And it's going to go the other direction and have an arrow on the end. So now what I want to do, because of this and means it's going to be an intersection. That means that we want to know where they overlap. Where do they both include? So basically I'm going to draw a third number line underneath and put in wherever they both cover. So they both have 3, and then they both have all this stuff in the middle all the way till you get to the -1, and that one wasn't included on one of them. So this part right here is where they've overlapped. This is where both of these graphs would cover. Okay, moving on to number 3. Number 3 says x is greater than -3 and x is less than or equal to 4. So again, I'm going to graph them. This time I'm going to go from -3 all the way up to 4. I made mine a little too small, sorry. X is greater than -3 means it doesn't include -3, so it's a circle. And it's greater, so it goes this way. And there's an arrow on the end. And then we would have a second number line. I want to make it the same numbers. 1, 2, 3, 4. It says less than or equal to 4. That means it includes 4, so there's a dot, and it goes this way. So now I need to know where those overlapped. This is my actual answer. Make sure you understand this third one is really your answer. So if you're putting your answers onto the packet, that's the one you want to graph. This one says it's greater than -3, so we're not going to include -3 on both of them. Should have a circle there. And then it went all the way to 4, so that was our dot. And obviously have all the numbers in the middle. Just going to save some time by not putting them all. So it looks like that. Moving to number 5. -3 is less than D, and D is less than 2. We always want to write this over so that the variable is on the left. So move that around. Make sure it was trying to eat the D. It's got to stay eating the D. So flip that around. Then you can do your 3 graphs again. We want to go from -3 all the way up to 2. I guess I could go to 3 if I left extra space. D is greater than or equal to -3. Means there's a circle, and it's greater, so it's got to go to the right. Then our second graph, whoops, let's try that again. Our second graph, I'm going to use the same numbers. And it's less than 2, so it doesn't include 2, so it's a circle, and it went this way. And then our third graph, which is the actual answer, is wherever those both covered. Well, they had a circle at -3, and there was a circle at 2, and everything in between should be included. So they're shaded in between there. Okay, and those were the only 3 you didn't really have anything to solve first. The next section you'll be doing some solving too. Number 7 says 4 is less than W plus 3 is less than or equal to 5. Okay, this is another way to write an AND statement or an intersection. You can write them all together like that if it's an AND. But in order for us to get W by itself, you need to break this into 2 things. So I'm going to write it as 4 is less than W plus 3 and W plus 3 is less than or equal to 5. Alright, and then I need W by itself, so how would I normally do that? You should know to subtract 3 from both sides. You get 1 is less than W. Rewrite it so W is on the left. Over here, same thing. Subtract 3. W is less than or equal to 2. So now these are the statements that I'm going to have to graph. And again, we're going to use the 3 graphs because it's easier that way. Our graph doesn't need to be very big this time. We only need 1 and 2. So 0, 1, 2, 3. W is greater than 1, doesn't include 1, and it goes this way. And then the second graph is the same numbers, 0, 1, 2, 3, and it's less than or equal to 2, and it goes this way. And then our third graph, which is the answer, should be the overlap. So wherever they both covered, and they both covered 2, and then they went over to the 1, but they didn't both cover the 1. So right there. Moving on to number 9. Number 9 is -4 is less than x plus 2 is less than or equal to -2. And if you're good at solving equations and inequalities and you're comfortable with that, you can solve this with it all together. You don't have to break it into 2 like we did the last one. There's my x, there's a plus 2 with it. In order to get rid of it, this time I could say -2 here, -2 on the other side of that, -2 on the other side. Because there are basically 3 sections this time, so you could just do that. If you don't understand that, you are more than welcome to do it the other way with the and x plus 2 is less than or equal to negative 2. And then you would do the same thing. Subtract 2 from both sides. Subtract 2 from both sides. This would give me negative 6 is less than x. And this would give me x is less than or equal to negative 4. And of course, we would rewrite that way. And could do the same thing here. If you do it this way, you may be comfortable enough that you could do this graph without doing 3. You could possibly do just 1. I know it's going to go negative 6 is less than x, so I know I'm going to start at negative 6. I don't include negative 6 because there's no equals here. And I'm going to go up to negative 4, so I've got negative 5, negative 4, and it is x is less than or equal to, so the dot. And if it's less than, it would go this way, and this one was x is greater than, if I went that way. It would be in between here. If you are comfortable, you can do that. If not, you can do all 3 graphs and find the overlap again. Number 11. They have n minus 2 is greater than negative 3, and n plus 4 is less than 6. So I'm going to add 2 over here to get n by itself. N is greater than 5. Over here I need to subtract 4 to get n by itself. N is less than 2. And there's an and. Alright, so if I did my 3 graphs, I need to go basically from 2 to 5 because those are the numbers I need. 2, 3, 4, 5. N is greater than 5. Alright, so it goes this way. And then the other one, my 2, 3, 4, and 5, says n is less than 2. Alright. Hopefully you see the problem here. They don't overlap. If they don't overlap, is there any way I can draw the third graph of what overlaps? It's impossible. You can't do that. So there is no solution for this. You can't do that. And let's flip to the second page. Basically, the first page had all and statements. The second page will have or statements, which will be union instead of intersection. So starting with number 1, it says b is greater than 2, or b is less than or equal to negative 3. And again, I'm going to draw 3 graphs so you can understand this a little better. I need all these numbers on there. Alright, so at negative 3, sorry, let's do this one first. B is greater than 2. So there's 2. And I need a circle, and it would go this way. Alright, and the other one, negative 3, negative 2, negative 1, oops, 0, 1, 2. B is less than or equal to negative 3. So there's a dot at negative 3, and it goes to the left. This is an or statement. That or is important. That means it is a union, which means we want anything that either one covers on this final graph. So on my final graph, I'm still going to have these. Negative 3 is right here. So I just bring that on there, and then I put the other one on the same graph. So the circle's on 2, and put that. This would be my answer. And these are a little bit easier. You probably could do this on just one graph because they go together a little easier than the other one. You wouldn't have to end up erasing. Number 3, we have y is less than or equal to negative 4, or y is greater than 0. So if we want to try putting them all on 1, we can do that. We can go from negative 4, negative 3, negative 2, negative 1, 0. y is less than or equal to negative 4. It means there's a dot at negative 4, and it's less, so it goes this way. And then y is greater than 0, so there'd be a circle, because it's not an equals, and it goes to the right. And that was pretty easy. On to number 5. Number 5 says negative 3 is less than d, or d is less than 2. I want to rewrite this one so that the d's on the left. So I'm going to say d, and this was trying to eat the d, so it has to stay eating the d. Negative 3, or d is less than 2. And again, we should be able to put this on one graph. So negative 3, negative 2, negative 1, 0, 1, 2. D is greater than negative 3. Alright, so I'm going to have a circle at negative 3, and then it's going to keep going this way. Right? All the way to the end. And then D is less than 2. I would normally put a circle on 2, but it's already filled in, isn't it? And if I'm doing an or, it's where either one covers. So if it's already there, I don't have to bother even putting the circle because it would be filled in. But it would go to the left forever, right? Which would cover up this circle and just make it everything. Everything ends up shaded because they overlap. Number 7. We have 3 is less than 3w, or 3w is greater than or equal to 9. So we want to get w by itself, so I would divide by 3 to get rid of the times by 3. That gives me 1 is less than w. Rewrite it so the variable is on the left. Divide by 3 here. W is greater than or equal to 3. And again, I'm going to put those on my graph. I'm going to go 0, 1, 2, 3, 4. W is greater than 1, so I would go here and go this way. And W is greater than or equal to 3. Well, I would put a dot at 3, but it wouldn't really matter because it's already covered. So it's already there. And we should be doing, I skipped this from the other ones, but we should be writing our answer to this. So again, in set notation, my answer based on this graph, my variable was W, the wall. On this graph, we know it's everything to the right of 1, which means W is greater than 1. So it should be that. Alright, number 9. 2x plus 4 is less than or equal to 6, or x is greater than or equal to 2x minus 4. Again, we need to get x by itself, so I would start by subtracting 4. So 2x is less than or equal to 2, divide by 2. X is less than or equal to 1. Over here, we want to get all our x's together, so I'm going to subtract 2x. That will give me negative x greater than or equal to negative 4. Multiply by negative 1 will give me x and 4, and don't forget, if you multiply by a negative, you flip that sign. And then I'm going to go ahead and do the graph. And I need 0, 1, 2, 3, 4, 5. Less than or equal to 1 means there's a dot at 1. It goes this way. Less than or equal to 4 is a dot at 4, and it goes this way, which covers up that dot. So it means my answer again, put the variable, put the wall. On this graph, we have everything 4 to the left. So x has to be less than or equal to, because it's a dot, 4. That's it. And the last problem is number 11. Number 11 says 1/2 n greater than negative 2, or 2n minus 2 is less than 6 plus n. Over here, I would multiply by 2 to get rid of that 1/2, which will give me n is greater than negative 4. Over here, I would say I want to subtract n first. That'll give me n minus 2 is less than 6. Add 2 to both sides. N is less than 8. And this was an OR. So I'm going to graph it. I need negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, whoops, 1, 2, 3, 4, 5, 6, 7, 8. Kind of ran out of room there. Sorry. N is greater than negative 4, so there would be a circle, and it would go this way all the way to the end. And then n is less than 8 would be a circle, which doesn't matter because it's already filled in, and it would go this way. So again, it's going to cover up everything. So my answer in that case is all real numbers. Anything would work because it covers the whole graph. All right, that is the end of section 6.4.